All right, and we are back. Welcome everyone back to the Friday Open Studio Design Session. Um, you probably are a returning viewer, to be honest, if I had to guess. So you already know what the deal is, but in case you're new, um, the point of these sessions every Friday on my channel is to really just spend some time and work on projects. Um, for me, this has been this F16 here that I've been working on for the past month or two. And so today we just want to really continue with this project, but really treat this as kind of a thing that you have on in the background, kind of like a podcast or something that you're listening into. Um, Feel free to put this on while you're doing your own projects, and just have fun. And hopefully, it's like a studio environment virtually through the power of the internet. Um, so last week we had some technical difficulties, which I'm really disappointed about. But hopefully, this week we won't have these issues. But if we do, then oh well. That's kind of out of my control. So we'll try not to get too upset about it, and we'll catch up really quick on what we did before the stream is interrupted. But for now, let's just go over kind of what we did last week and the plan going forward for this week. Um, Last week, we were working on the underside of the aircraft, and so that entailed making these ribs, which I can actually, let me just grab a couple of examples real quick. Um, so we were working on these cross sections that were cut, and then there's like an anchor bit that kind of tapes down to the underside, and then it was cut down the middle so that it fit perfectly. And essentially what you would have is a structure that would kind of look like this, right? So this is what we were trying to go for last week, making these individual cross sections. And as you may or may not recall, if you watched last week's stream, it was a very tedious process to make these, right? And we spent a whole 2 hours or so, and we didn't get very far. So I've actually taken the liberty to um, go ahead and make these sections with additional time outside of these streams. So right now, this is what it looks like. I'm pretty excited to show you guys. This is the current state of the F16 that I'm making. It looks pretty decent. As you can see, you have your longitudinal loft right here, and then your cross sections, which are perpendicular to that loft. And then these clips are there so that I can put the plane down without damaging, putting extra stress on a part. But you can see here that there's it's a pretty complex assembly, right? It kind of looks like a skeleton, right, of sorts from afar. It's kind of like a bone structure underneath like a living organism, right? Like something like your rib cage or something like that. But you can see I labeled them here: 1A, 1B, 2A, 2B. 2B is a little faint. You might not be able to see that, but it's there. 3A, 3B. And essentially the front faces are labeled A, the rear faces are labeled B, and they're sequential: 1, 2, 3, 4, 5, 6, 7. Back here I had an area marked out for an eighth uh, perpendicular face, but I decided not to incorporate it because I want to try and see if we can create the nozzle as is, without too many things in the way, so to speak. And so that's kind of the plan going forward. Today is really to finish up surface modeling this entire fuselage underside, and then smooth things out, and obviously just complete the nozzle structure back here, which is going to be very interesting because it's an axisymmetric part, right? It's kind of like a cone, but it's you want to add a little bit of detail and realisticness to it. So you're gonna have to cut like panel lines and things like that. So that'll be an interesting aspect of the aircraft to work on. But I guess the main task for today, for now, is really just to panel all of this together and just seal up this rigid, lightweight structure. But before we do that, I actually want to show you guys where the CG of this thing is, because that's going to be pretty important when it comes to flight testing. And so right now, as is, this aircraft balances right about at this point. So slightly behind this structural cross section right here. So right about here, right? So if you hold it at those 2 points, it balances just like that. Well, this is great, right? This is great, but in my preliminary flight tests indoors, just short glides, just tossing it like that, this is actually a little bit too tail heavy. So, we need to move the CG, the center of gravity, forward a little bit. And so I've marked out, kind of where it should be, which is not behind this member, but a little bit forward. And I've come up with a pretty interesting idea on how exactly to integrate that extra ballast weight. And so, when you think of ballast weight, you typically think of coins, right? Because at least that's what I use, because they're directly made out of metal and you don't have to buy anything, right? Coins are nice that way. The only thing that they are bad at is, their footprint is massive. It's absolutely massive. So what I've done is I've actually taken some coins. These are quarters. I actually don't need quarters. Quarters are, they're weighty, but they are way too massive, right? As you can see, this is about the width of this entire forward fuselage nose section. So this is not usable. What I've done is I've actually taken out all the pennies from this. I think I took 6 pennies, which is quite a lot of weight for ballast, but that's what you have to do when you can't place a little bit of weight, far forward in the nose, because we've already sealed that up. I'm sure we could open this up and slide a weight in, but it's just, I don't think it's worth the hassle. So, we might end up doing that, but, chances are we're probably not going to do that. I found that 6 pennies also gives the aircraft a decent amount of weight, which is kind of like its fuel, so to speak, because this is an unpowered glider. You need a little bit of mass to drive it through the air, right? And so I've took some pennies, which I don't think there are any more. I'm using the last of my pennies. I need to trade some quarters and get some more pennies, because you get more mass that way, right? So it's fairly cheap. This is about 6 cents right here. What I've done essentially is I have taped them together, right? I did not use double-sided tape. I used single-sided tape. You do that thing where you loop around the sticky side onto itself, right? And then it'll be like 7/4, 3/4 of an inch, 7/4, 3/4 of an inch in width, and then you cut that in half and you squish it down, and it happens to match up with the footprint of a penny pretty well. So you can actually see some of the tape squeezing out of the sides here. And what I've done is essentially tape everything into this nice stacked structure, right? If you have a white background here, you can see that it's not a perpendicular stack, right? It's a slanted stack. And what that enables us to do is, bring this together at an angle and have everything be compact without sticking over the sides here. And then this is important because the way we're going to integrate it with this fuselage is to actually just put it in between the 1 and 2 structural members here, the perpendicular cross sections. So you'll see that this has a little notch right there, right? You might be wondering what that notch is for. Well, it fits right there like that. So I think this is a pretty clever method of integrating ballast, right? It's a very clean design. The only downside to this is potentially the high amount of weight that's needed to create that balance. This is 6 pennies. It's a lot of weight, right? We might have to take weight out, but hopefully, when we skin the fuselage, it'll balance out the weight a little bit better. But this is kind of the current method. If we zoom out a little bit, you can actually notice that, okay, so it's not taped in, obviously. That's why it's shifting around. But once you put it in here, it barely comes out the sides and the top, right? It's taking literally the chord between this midpoint here and this edge right there. So it's taking that chord and, resting upon this cardstock structure securely. Because if you just tape it down here, right, the footprint is a little bit too big. It'll actually come out the footprint a little bit, right? So you'll be outside the the panel, the skin. So to really keep everything in place, we are taking it into the depth dimension, right, by putting it at an angle, sliding it in, and it happens to work great. So this is a pure coincidence, right? I did not measure this beforehand. This is just one of those things where it's like, when you go by gut feeling, when you size things, you have kind of an idea of how things will fit together. And it's like not, conscious thought. You just kind of have a feeling about it. And this is just really developed over a lot of experience. So in case you're wondering how I did it, that's kind of the gist here. So before we skin the thing, that is, cover the whole thing with cardstock panel material, we are going to have to secure this really tightly, because it does come out a little tiny bit, but when you apply pressure, it actually it stays within the shape of the cross section. So that's kind of the first thing that we're gonna do here, is we're gonna try and secure this really very tightly against this in between these number 1 and number 2 cross-sectional members. So we'll be doing that, and to do that, I think I'm going to first apply tape this way to keep everything in place. But I also think we also need to apply it the other way, perpendicular to that, just to add some strength. We might also end up using a little bit of glue, because it's an awkward position to really tape things in. So I have some glue ready on the side, but we might not end up using that. All right, so here we go. Let's hope that this is long enough. All right. So I think this is maybe long enough. Let me check the chat real quick. Benjamin Rogers, very nice. Thanks, man. I appreciate it. You do some pretty cool projects too. So I would love to see videos or explanations about that. So we can try and assemble this. This is going to be very interesting, because what we need to do is compress this in at the same time applying adhesive while it's being under pressure. this is okay. This is doing all right. Okay, so the problem with this is that it still jiggles around a little bit when this tape comes loose, which is not ideal. Just thinking about a good way to secure this. I think we might need like another band here. Maybe like 2 more bands. One band here, one band near the back to cover that, and then we're gonna cover it like this. So again, with these projects, I really don't have any idea what I'm doing. I'm just kind of going with the flow, right? But you have more opportunities if you spend more time, right, to set it all up, right? With these cross sections, I've created these gaps where you can install different things, right? Like you could technically install landing gear in here, but I'm not gonna complicate this project anymore with that. I don't know, maybe for a future video I can like disassemble parts of this F-16 and upgrade it with a movable landing gear thing. I don't know. Let me know if you would be interested in that, but I feel like that's gonna be pretty complex, right? The landing gear itself is gonna take weeks to build, because it's it's very small, right? The scale is one thing, but also it's just very time consuming. So instead of actually cutting this, I feel like a full band of tape could do the job. I probably should have started with that to begin with, but I didn't know if it would fit. So let's just overlay those 2 layers with another piece of tape here. Yeah, compress it in, compress it down. Really just get the tightest fit possible in here. All right, looks pretty good. So what I'm gonna do now is, all right, so we have this, I don't really like the scrap pieces that I cut off. They are getting in the way, but I'm gonna try and actually, so this slat mechanism slides a little bit along the axis, so I'm trying to fix that gap, but honestly that it's like not a huge issue in the grand scheme of things right now. Let's just cut this, right? Cut it like that, and really just rip it. Tape rips like butter once you get it started. It's just a material property that you would learn about if you use a lot of tape, which quite frankly I do. It's a huge part of the structure in this design, or rather in this method, right, I should say. Okay, so now we can trim this side. Okay, it looks pretty good. Might have like a little bump there, but honestly it's such a small detail, it shouldn't matter too much. I feel like we could like make a fairing out of that if we really wanted to make everything smooth, and it would look pretty realistic. It wouldn't detract from the overall design. So just for safety, I guess, we're gonna add longitudinal pieces of tape like this really just pinching this together to really secure that. I mean, I say pinching, but it's really not doing that, right? It's how do you say it? It's it's more of a safety measure, right? In case these lateral tape pieces collapse, you still have something here to support the ballast structure. And the ballast is usually the first thing that goes when you crash. Um, like the coins just like fly off of the plane once you crash, because the acceleration is pretty sudden, and these things are relatively massive, right? Because they are ballasts, so they hold a lot of mass, right? So you got to prevent them. This is essentially like giving your passengers a seatbelt, right? If you've ever done one of those engineering projects in school where you have like an egg and you're trying to throw it off like a balcony or something, and then you're trying to protect it with a parachute because of you prevent it from the shock that you experience from hitting the ground. This is kind of the same idea, except instead of eggs we have coins, right? This is a ballast, and instead of protecting the coins, we're really protecting the plane, because if we didn't tape this well enough, it could rip out of this paper material, right? This is only paper after all. It's not like a steel or anything strong, right? It's just for peace of mind, for reliability standpoint, we want to do things right, so we just reinforce things, way over reinforce things, right? And that's gonna make things a little bit more durable, and you can handle these shocks, instances of shock, right? So I think for shock, the mathematical idea behind it is you have position, right? So you have your x, y position. You have your first derivative of that, which is your speed, your velocity, right? And then when you take a derivative of velocity, you get acceleration, which is what you apply when you exert a force. You accelerate a mass, right? F equals ma. But shock, jerk, is the derivative of acceleration. So you take one more derivative, and it describes how sudden your acceleration is changing, right? It's a kind of a difficult concept to grasp if you don't really, I guess, know. But if you're exerting a certain amount of force, and then you all of a sudden exert more force, right, or gradually increase force, and then something is accelerating at a faster and faster rate, if that acceleration is changing, then you're applying like a jerk, right? You can search it up on Wikipedia. It's pretty interesting. There's like multiple derivatives of position and whatnot. Now let's see, the center of gravity is right about here at the root of the leading edge slat, right at the trailing edge, right? So we've moved it from back here, right, back here behind this structural member, to right about here. So that little distance right there, half a centimeter or so, really does make the difference in flight. And when we install all the skin panels covering all of this, it's gonna bring it back a little bit, so it won't be too nose heavy. Because the way I have it right now, it's a little bit nose heavy, but it's not too bad. So we'll definitely tune this more as we get closer to a flight test. But for now, we are going to start to panel this, which is going to be a very exciting, very interesting part of the project, right? It's supposed to be one of the easier parts of the project, but honestly, at this point, because we've spent so much time developing this canopy, which looks really nice, it might take this session and then one more to complete this paneling, but really want to do it well, so it will take a little bit of time. And we also have the nozzle in the back, and after that, I'm thinking like applying a decal with my logo to the tail here. but that should be a pretty straightforward process. You know, this is looking nice. You know, the 3D aspect of this really gives it a character that's just not there when you have a 2D cross section. It's just it gives it more volume and presence. I feel like, you know, you can't really describe it, but it feels more like the real thing, which is good, you know, because we're going for a realistic look. Um, all right, so to start our paneling process, I have cut some paper, right? I've actually, you know, I got curious, so I guess I wasn't supposed to work on this, but I got a little bit curious and I cut out a rectangle and, you know, tried fitting it around this to get a better feel of what it's gonna look like. And so far it looks good. It doesn't look too great, but I think it looks decent for what it is. Um, we'll definitely have to like take it in panels, like this, right? Instead of doing one long panel, because I feel like this long panel is just not gonna work out, right? There's too many places where you have, you know, curvature changes and things like that, and it's just gonna look very rough. So we're gonna take it one section at a time, probably going laterally like this, right, covering the aircraft underside. So the first section would be, in that case, it would be the intake, right? So the intake is gonna be interesting. I think we can use this as kind of a measuring stick of sorts, right? This is gonna give us the info that we need. If we want it to fit exactly with no overhang or anything, it's gonna be this long. I'm thinking for the intake, I also want to incorporate like a lip. Even though, you know, this thing is not hollow, we should probably include a lip to make it not like a sharp, flat edge. What I mean is, like, if you curve this, right? Let's actually mark that out real quick before we continue on and do other things. All right, so actually this crease marks where it is. So this is approximately 5 centimeters. Wow, exactly 5 centimeters. That is pretty nice. That's a nice whole number. What we can do is get that 5 centimeters right here. And then, you know, so it's gonna be pretty constant cross section up until this point. So we'll have to try and, you know, really keep that in place. Also, we want to get the depth, right, or, you know, the longitudinal length. It's also about 5. It's a little less than 5. We can make it a little bit more than that, which is 5. So essentially, we're cutting out a 5 by 5 centimeter square. Should be like about right. You can always trim down with excess, but we can't add, at least not reliably, not in a clean way. So we'll go with a little bit extra and go with the 5. Right, so I'm literally just using the ruler's base here as a right angle. You really shouldn't do this, right, unless it's, you know, the ruler is certified to be right angle, but for my purposes, I think this is good enough. This is a paneling job, right? Paneling isn't accurate in the first place. It's literally up to you. It's kind of like an art in that sense. Oh shoot, I lifted the plane a little bit. Yeah, let's put the clips back on so that we don't damage anything. So the nice thing about this design is that the clips actually fit inside these areas here. Very nifty. It was not purely by design, but I just kind of noticed it. It fits perfectly in one of these notches. So just gonna leave that to the side. Right, we have a 5x5 square, so it really doesn't matter which way we line it up against the underside of the fuselage. I'm gonna cut this out. Also, can you guys believe it's like already October? It's like, dude, where did time go? Right, it's been a week already. But anyways, that was a random side tangent. My brain works in mysterious ways, you know, I get distracted easily. But, you know, part of that is I want to say like I have a condition, but I really don't. Like I'm not officially, you know, I don't have like a condition assigned to me by a doctor, but I get really distracted. Like I think about random things all the time. But you know, it makes you a better designer to be curious and you know, not have a linear train of thought. But it makes you a terrible. I guess not terrible. I wouldn't say terrible. It's just not as effective of a proper engineer. But yeah, linear thinking is kind of boring to me, and I'm not really great at it. It's like this, you know, this tendency to think off track. You have to temper it with some sense of direction of logic, right? Because if you let pure creativity go unchecked, you get these crazy designs that you build that don't work, and it's like, oh, I'm disappointed. But you know, at the same time, you didn't really test it out, so, or you didn't really do the proper, you know, the considerations behind such a thing. So, you know, anyways, that's like kind of meta, right? That's about, you know, design, you know, state of mind, right? What you're thinking and how you approach problem solving, which is a little bit meta, but you know, this is what happens when you let me go on a rant and I talk for 2 hours straight. So right now we're just curving this cardstock piece, right? Just pre-bending it. This is to allow it to have kind of a better fit with the underside here. So you'll notice that this will fit much better than, you know, if we took a straight piece of paper and then, you know, try and, you know, wrestle it into shape, right? If we bend it into the shape beforehand, it'll handle the, you know, the extra, I guess, applied displacement easier, right? It'll be a little bit easier. All right, so this is kind of what it looks like right now. Ooh, 5 centimeters is a little bit tight. I think it's because of the coins, right? The coins are slightly stuffing the intake a little bit and making it pop out a little bit more. So, all right. Yeah, the coins are definitely applying a little bit of displacement to the cardstock, so it's not getting a tight of a fit as I'd like. But let's see if we can work around that. Let's just see how this fits, honestly. I feel like it could work. We'll probably have to do a transition panel in between the seams anyway. But let's just see how this will work. Alright, this is a complete experiment. I have no idea if this is gonna work or not, but we're gonna give it a go. See how we do. Alright, so we've done a dry fit and taped down one side here. Oh, that is quite a large gap. Dang. I was hoping for tighter integration, but you know, sometimes that's life. You don't get the tight integration that you need. I'm also wondering, like, if I cut the front, I'll probably be able to overlap a little bit, like the front panel, so that, you know, this tapers in a little bit, because I think that's a design feature in the real life aircraft. So I want to try and see if that works. Also, this is like very rigidly cylindrical, which I don't know if that's the best way to go with this. So if we cut it down the middle, we might be able to, shoot, let me just put this clip on. We might be able to put the red clip in the back, because that's what I've always been doing. We might be able to curve both sides in a little bit and give it that kind of a V shape, very slight V/U shape, which would make it look more like the intake itself. So we zoom in closer. We're gonna measure out 2.5 because we know it's 5. Honestly, we could have gone with 5.5 and be safe, but we didn't. So here we are with a little tiny gap on the side. But really, I feel like for the rest of the paneling, 5 is actually enough. It's just literally this front portion is, you know, there's a set of coins underneath that are acting as ballast. So I am going to cut 1 centimeter in. Alright, so that should allow us to overlap a little bit. Like grab the piece of tape that I had here. Alright, I'm just gonna tape it to one side here, and then see how we can get by with this. This center mark and cut also helps us to align everything in place. All right, so that's not gonna work. Get tighter, panel there. Oh, I just tape the other side here and try and make it work. This is literally the most difficult thing that I've done ever for paneling. You thought I was going to say the most difficult thing ever, period. Oh, no, there are harder things that I've done. Okay, so this is looking rather interesting. This it doesn't look too bad. It just looks a little bloated, to be honest. Maybe I cut the cross sections a little too wide. What if I pushed in this edge? And also pushed in this edge. Okay, so this is kind of what it looks like right now. It looks a little strange. It's a little bit wide. Well, honestly, I don't want to change the cross sections at this point. I just want to finish this project. So I don't know, decisions. Decisions. I don't know, like something about this feels off. So I'm gonna reference like a real life picture real quick. Shoot, I can't even clip it now because because it's in the way. All right, let me take out my handy iPad real quick. Take a look at what makes an F16 side profile look like a side profile. I think it might be the diverter, diverterless, not diverterless, the diverter splitter plate. Shoot, this doesn't work. It's also like not that obtrusive. Oh yeah, it's definitely a little bit wide, I feel like. So the real life thing ends about here. No, okay, so the width is okay. It's just the panels for some reason make it look fat. For lack of better terminology, that's the way I see it. It looks a little bloated. Let's see. I got another comment. All right, just hold on for a sec. I'm adjusting my chair. All right, so what was that chat? It's a long ass comment. Anyways, Dustin M says definitely underrated channel. Love the aircraft and designing. I'm gonna head out for now because of school, but hopefully we'll be back before you end the stream. Have a good one till then. Thanks, man. I appreciate it. As long as I reach one person out there who values this stuff, and my job is mission accomplished. Benjamin Rogers says, I built a glider for my egg drop project high school. LOL. Yeah, it's a very standardized engineering project, right? And then they make you like write a report and stuff. I had a similar thing. It was like a water rocket launched egg. If you go back on my Instagram far enough, you might be able to see some pictures of it. I did some sketches, and then it was literally a 2-liter soda bottle with like a O cross section, right? A donut cross section that you could put the egg in the middle, and I made like a tab and slot construction, like a sliding thing for the egg, and then I put like a Ziploc bag that's like taped shut with full of air, right? So that would act as a cushion for the egg as it crashed into the thing. But it's an interesting design. It's from when I was rather inexperienced when I was working on these projects. So it's not great, but looking back, it's pretty cool progression. I don't think I could do anything like that today, just simply due to resource constraints here. Um, but hopefully maybe one day, I'll get myself a house. Hopefully within the next 2 years or so. That's the current plan, and then I'll be able to get started on creating my workshop in the garage, so to speak, and I'm gonna make it work on larger projects and more involved projects. And that'll be definitely a step up from these paper airplanes. But for now, we're gonna do the most with what we got, which is this stuff right here. So you'll notice that I just cut this side panel to get a better fit, right? I'm gonna remove this piece of tape here. So really, this is more of a MacGyver type channel than like a proper engineering channel. But I treat these things as, like, again, something in between art and science rather than one or the other, right? I think that's where the magic happens, is when you make cool things, good looking things, but also things that work, right? And so that's kind of where I like to operate here. So thanks for the kind words, guys. I really appreciate it. Just ripping this little piece off here so that we get a better fit. This is like a taper fit, right? So the intake appears a little bit smaller in the front, but really is actually quite voluminous if you look at it carefully enough. This is actually a little big. I feel like the cross section is a little wide. I could have done with a narrower cross section, but this is the one that we have, so we're gonna stick with it, I guess. I will actually, since this is mostly for stress relief, but I could actually create a lip right now, so I'm gonna do that. I feel like accent colors on this plane should probably be white. So I don't have white cardstock with me right now. I'll try and find a sheet real quick. This is it's a very minute. I mean, I guess we could use regular print paper. It's just we might need multiple layers. This isn't like a structural piece. I don't think it will be a structural piece. It'll probably crash nose first, but not intake first. It's because of this extreme angle here, right? When it crashes, it'll likely crash at an angle like this rather than a very shallow angle. But I don't know, this might be like a structural weak point right here. Just want to make sure that I am taking the necessary precautions here. Just clean up a little bit of this stuff on the side. It's a lot of excess tape. There's a guy years ago. He was also huge in the paper airplane business, I guess, on YouTube at least. I think it was like No Offense Pies or something. It was like years ago, over 10 years at this point. And he was like, dude, you use way too much tape. And I was like, dude, my planes aren't taped. What are you talking about? But it's funny. I just remember that comment. Dude, you use way too much tape. I'm like, bro, my planes aren't taped. But yeah, tape is really powerful when you think about it. It's like it's an adhesive, but it's also structural because it literally is plastic, right? It's very strong in tensile strength, because you could try yanking, like if you take a strip, I'm not gonna do it now, but if you try yanking it, it's actually really difficult to rip it. It's only really weak when you introduce a cut, which is a very sharp notch, and then you apply force, and then there's a stress concentration at the tip of that little corner, right? and that's gonna rip it. That's gonna amplify your stress because it's a very small area. Um, and that's kind of what I do at my job, except not with tape, but with like metal parts and engine parts. Look at those types of things, but it applies to everyday life, right? Because if you think about it, when you open a packaging for like a bag of chips or something, you're essentially using that principle to rip open the bag, right? You're applying high stresses to that bag material, um, with the zigzag lines at the top, right? You apply that stress, and then you're able to rip through the material. So you think about it, engineering is everywhere in life, right? Everything that you touch that's been human made or interacted with is probably created by engineers, and designers, of course, but designers less so the technical stuff. I'm talking designers like as in a general sense, not like engineering design. That's different, right? That's a totally different field than regular, just consumer product design. That's different. Um, Although I do find that very fascinating. It's not a very technical field, right? It's more like art and design, that kind of design, rather than engineering design, right? There is a difference. So, but that's kind of going off on a tangent again. I'm sorry about that. I don't really focus too well. Um, I was supposed to do a rotation as a design engineer, but because right now I'm a structures guy in a pretty big engine company. But as a designer, you get to actually define, what your requirements are, what you need, what you need to make the shape look like, how much, right? What material. That stuff is interesting to me. I'm not saying that structures isn't. I'm just saying that stuff probably is more up the alley of my career interest. But who knows? Maybe I'll stay in structures for like 30 years, and I'll be a very experienced dude telling you don't cause stress concentrations, make your fillets rounder or something like that. You know. All right, so I'm gonna introduce a 5 centimeter wide lip, and it's gonna be I want to say like a centimeter and a half deep, because that's gonna give us the perfect amount of overlap here. And we're literally doing this for aesthetic purposes, but it's it could be structural. I'm not too sure actually, but I'm gonna try and do this. So this is gonna be 1.5, and then we're gonna make a little lip. So it's gonna be double layered. It's gonna be wrapped around this forward intake lip structure thing. On the real life plane, this is usually defined by the airframer, right? So in this case, F-16s are produced by General Dynamics, which is now part of Lockheed Martin. At least this aircraft program. So Lockheed would be responsible for making the inlet structure, and then the company that I work for, Pratt and Whitney, is actually the maker of the F-100 engine that goes into the F-16, the real life F-16. But I don't work on that program. I work on commercial programs. But it's pretty interesting seeing how these companies interact. To Lockheed, we're just an engine supplier, but to us, we're like, our company's like, we are the heart and soul of aviation. and you think about it, it's really true. But it's funny because the engine airframers don't like to admit that. They often like to say, we own the propulsion system and like we define the requirements, but they don't actually make the engine. They're just there to integrate everything. They're really an integration kind of business, really. No airplane company makes the airplane. by itself, at least not in these days, right? 'Cause airplanes are very complicated, so you have like different companies acting as suppliers for other companies and things like that. All right, so this is looking okay. This is not too bad. I feel like it would have been better if I taped the inlet structure in place first. Okay, so this is looking really weird. I don't like the visual. I don't like the visual look of this. This is like, you know what it looks like? It reminds me of the X-32 laughing. This plane looks like it's laughing at me. All right, so I'm not sure about the color white. We might actually end up sticking with the gray cardstock here, which in that case will kind of suck. We'll have to probably disassemble this. But for some reason, this forward part just looks so fat, right? It doesn't look right. I'm trying to think about this. It really should be a little bit narrower, but from the cross section, from the drawings, it doesn't seem like that. So I don't know. I honestly, I'm at a loss as to what to do here. Probably disassemble it to see real quick what I can do about it at this stage. Because really, this problem is a cross-sectional problem. It's not a surface modeling problem, because I don't think my surface modeling is off by any measure. It's literally the the underlying bones of this thing is it's too wide. It doesn't look that bad, but I guess it really is bad. um, for lack of better wording there. All right, so I might, we could try splitting this intake into two parts, one just for the forward here. But there's like no bulkhead, so it's like not structurally reinforced. So I don't know if we want to do that, because the reason why we're doing this 5 centimeter piece is that it covers these two, number 1 and number 2, structural bulkheads, right, with the weight in between. So this will be like a very strong structure. But what I'm saying is, if you do that, then you might not accurately portray the narrower portion of the inlet here, right? Because it's hard to get it to taper and go this way. So this is essentially like a cone shape, right? It goes thinner here, and in terms of width, it also comes up a little bit. It's like very slight, but it's there. So to capture that, we'll probably have to split this 5 centimeter long panel into, I don't know, maybe this could work, just a little bit shorter. It's really going to be a little bit difficult and ambiguous, right? This whole project has been ambiguous. We've been doing everything like ad hoc since the beginning. So it's actually kind of amazing that we got to this point. But that aside, I think, for the intake, this is really gonna be difficult. This is like next level stuff right here. We could tape a piece of cardstock here to the side and then fold it across this, and then get it to that other side, and then duplicate that shape for the other side. So like essentially like a structure kind of like this. So if you zoom in a little bit, it's gonna look like this, and then it goes up until a certain point, right? This is this actual bulkhead, right? And then we bend a piece like this, and then get it to stick right here, and then we have the other side, right? And then you would have your intake structure. Well, that's just like a little bit too complicated. I don't want to do that. Yeah, the troubles of modeling. And this isn't like a closed structure either, because if it were closed, we could make it smooth in the end. This is like a cut short intake structure thing. So I don't even know. I guess we could like continue with the rest of the design and figure out that later. But that's really just tossing the problem for later me, which which I guess is okay. I can do that. Later, me will be disappointed, but I will be happy in the moment. So let's just continue on and not worry about that because we need to keep this show going. All right, let me just grab some card stock real quick. I'll be right back. All right, I got a sheet of card stock. I'm gonna turn on the lights real quick. Okay, you probably didn't even notice that, but it does make a difference in the room having another light source. All right, so what we want to do is panel the rest of this thing. The front, we might just do like a feathered structure here. I just thought of an idea, like you have like a solid piece here, but then in the front you like make several cuts like that, and then you can actually shape it a little bit better. I don't know, that's just an idea. We may or may not do that. I honestly do not know at this point. I don't know for sure, like we should cover this at least a little bit over when it comes to the rest of the intake. I feel like we should do a little bit more than 5, maybe like 7 centimeters thickness, because that'll give us a little bit wiggle room here on each side to really flatten things out and tape it down. I don't know. The other dumb thing about this thing is that the cross sections aren't even. That kind of sucks. Like I would think that it's a little bit better than using a straw, but we might find out the hard way, the arduous and difficult way, that this is actually not great. But with CAD it should be better, but I don't have CAD right now. Like I'm literally, my only computer is like a Mac, and there are no good 3D software for modeling on Mac. So I have to get myself a PC soon. Let's see. So this, all right, we can try and model up to this point, which would be, we have a little bit of overhang. How long would that be? Let's see. Let me get a rough measurement here. It's like a half centimeter overhang. So that's about 9. That's 9 perfectly. Wow. Okay, so 9 and 7. So those are the two magic numbers. So we want to do 7 for the width, I want to say. Let's see. Actually, we can use a ruler like this. All right, so we want a little bit of anchoring material here, and you bend it over, and then you also want a little bit of anchoring material here. It's gotta be tight integration right here. All right, so that's right there. All right, just make that crease a little bit more obvious, and then measure this. This is about 6.5. All right, so 6.5 it is. We're not gonna go with 7. I was pretty close though. 7, 6.5. That's only half a centimeter, which is a lot if you think on a small scale. But if you think on a big scale, big brain energy. It's not that bad. So let's see. What was it? 9? Yeah, 9. 7 and 9. So we're gonna want to rotate this. Oh God, remove the scraps out of the way. Yeah, I think I'm gonna go with like a gray intake lip. Notice like on this X47B here, the winglets have that same type of construction, like a double layered wrap around, just to reinforce the tip here, cover up the split ends. And it's pretty solid structure, so I think gray cardstock is gonna do the trick. Right, what was I? 9 centimeters? Yeah, there we go. 9 centimeters. up until here, and then we're good. Okay, and then 6.5 centimeters. Really shouldn't be doing that because it's not a good way to get a rectangular area here, or rectangular shape. There we go. So this goes up until 9, but we're starting at 16 essentially, so 8. I don't know. I'm just eyeballing this at this point. This is like hella sketch, dude. Like, is this even 6.5? No, it's not. You see, this is why we can't have nice things. Alright, yep, just gotta correct this line. Oh, wait, where did we go here? We went to the 6.5, which is right about here. And then this will do the trick. Is this 9? This is 9. Alright, great. See, it's so hard without a right triangle. Wish I could just do everything in CAD and then print it out. That would be like exact. But I am not at that level yet. We will get there. When I can do that, I feel like this hobby is pretty much gonna be dead, because once you start computerizing things, there's no fun in paneling or anything like that anymore. It's literally just laid out for you, like the exact amount of material that you need, which I guess is like good for efficiency purposes, but I'm just talking to myself again. Dang it. Alright, let's see. Any new chat? Alright. I've been actually thinking about making a basic overview video in some of my projects, Benjamin Rogers. You should. I think it's definitely good for like documentation, just to know, what you did and things like that. Even if it's a stream, a 2-hour-long stream. You don't even have to like edit it. You could just do a stream like this, and then it's there on YouTube if you want to go back and refer to it. Yeah, I'm like trying to think like what's a good way to create these summaries, right? Like, because every couple of streams I should probably create like a video of a summary. But then again, I'm shooting with my phone and I'm live streaming. I don't want to worry about video editing, which is why I'm doing these streams, because it's pretty low effort if you think about it. You just do whatever you do on camera at a specified time every week, and then people can watch and listen in, and you make your progress, and this is like the full uncut footage at the end of the stream, right? So it's literally all of the documentation without taking up any storage on your local device, which is huge, right? Because my local device is pretty much full at this moment. So, I tend not to want to use that. And this, okay, yeah, this looks whack. This is like way too thick. All right, we need to bend this into shape. But that's the whole appeal with streaming, is that you don't have to worry about these bad footage bits, and it's all part of the whole thing, right? I like to not worry about the communication part of these things, which is why I do the streams, because it's you don't have to edit anything. You can definitely sit through a 2-hour video and edit, but I just don't find that to be particularly fun or engaging. So I'd rather be making things, and people can observe if they want to. But it makes, yeah, I agree, it does make it difficult to have like a nice little summary, because honestly, those YouTubers that make a lot of things, um they're pretty amazing, like at documenting what they do and telling like a story. I don't think I can do that. Like, okay, maybe I can, but it would take so much effort that it would detract all the fun away from this this hobby of making these planes. So I don't know, like on one hand I do want to like make good videos, but I just like, there's like this bridge that I have to cross yet. It's this bridge of how to convey a compelling story, right? Because to me, these things, these planes, they're great and all, they're beautiful, but not everybody sees that. And some people are just interested in how did you build, right? Like, or why did you build? Some, they have some interesting projects out there, like like a basketball hoop that moves around, right? Or things like that. And, they document everything, and that's like fun and engaging to the viewer. But these things that I do, they're probably not that engaging to the average Joe anyway. So for those people that are into these, airplane models and details and things like that, I feel like these streams are a little bit more appropriate for that. Um, compared to actual summary videos and things like that, because I don't think the amount of effort put into that would reflect the value behind each of these projects. um, at least that there's that, and then there's also the fact that I am a little lacking in terms of video editing, so maybe like that's something I should try and get better at. But it's just a little bit difficult for me to make those types of videos, those fun, engaging, summary type videos. Um, I just like showing the thing in front of the camera, telling a story through my own words, like just as plainly without much edits at all, and then try and convey like a summary through that sense, without any flashy like b-roll or anything like that. But I have been investing in equipment, right? Like I do have like a better camera now, but I'm still trying to like figure out how to shoot good footage. Like I shot a video, and it could be edited, but I don't know if the footage is good enough. I just need, I need a little bit of time. I need a little bit of time to really hone in on my video aspect of the hobby, which is also going to be quite involving. And I really can't do that until I have like a proper workstation. Right now, like I'm running off of a MacBook Pro from 2014, right? The specs are outdated. I can't link them up to my Thunderbolt 3 monitors, and it's just a pain in the ass to like edit things on that machine because it's just really slow, and I only have iMovie on there. I did buy LumaFusion on iPad, but there's a problem of how do you organize all your storage, right? And that's where I think like an actual PC, like a Windows machine, would be pretty helpful. Is a file management. It's a lot easier on Windows, I feel like. And so yeah, like I'm not a complete Apple fan, like their laptops is still a little bit difficult for me, at least, to use, for my needs of 3D modeling and CAD work and video editing and things like that. But yeah, then again, I got off on a tangent there, but I feel like, yeah, it's a great idea to make these like summary videos, but for me, for my limited audience, I don't know if it's worth it, and I'm not great at it, but I'm open to the possibility of exploring like a better workflow there. And I say I am, but like honestly, I've been a little bit lazy when it comes to video editing. It's like when I finish a project, when I physically finish building a project, I'm always like, it's done, I can just show it off, and then that's it, right? But really, the video is like a project long effort. You can't just start making a video at the end, because by then your whole thing has been assembled and it's already made, right? So it's no fun so to speak, to watch a finished product being displayed, I guess. But I find that to be more compelling. Like I can tell my story better that way. But the most engaging content on YouTube and things like that have, in my experience, been the journey through making XYZ thing, right? So I don't know. I'll have to explore. I'll have to explore like better ways of conveying that message. The story of how I made something. Um, yeah, that's definitely something I need to improve on. And yeah. So again, sorry for that like deep tangent. It's just I get like worked up about these things. I've been thinking a lot about these things, right? I don't just talk without thinking. I guess at least I don't think I do. I actually put thought into these things off camera and not on these streams. About how to improve the channel, how to create engaging, lasting content, right? I don't want my content to be evergreen or to be not evergreen, right? And what I mean by that is if you make your content like relevant to like a current event, like the recent iPhone or Galaxy or Pixel phone, it's not going to be relevant in like a year or two, right? But these projects, I want them to last longer in the sense that people years from now look, oh hey, look, an F-16 model made by this guy, that's gonna be evergreen, right? Because you can watch it any time into the future and it would still be relevant. It's a piece of history. This aircraft is a piece of history, right? Instead of the newest phone, which lasts about a year before the, the next model replaces it. So that's kind of the philosophy that I have about these projects. I want them to be evergreen, right? And the videos to be good. I have in the past tried to make like great videos, and you can tell where the effort has been put in to making a better, I should say better, not great, better video. Like the Astra, for example, that was a very involved project, so I attempted to tell a better, more coherent and well done story, like that. But that was a probably one in like a 1 in 10 of my videos are like that. It's not that much, right? In high school I made a video about designing aircraft, which you might have seen is like it has like 20 something thousand views. It's okay. I would say it's inaccurate now looking back, but at the time I had this this romance going on with like aircraft design, right? Like it's just such a beautiful thing creating beautiful machines that fly. And sometimes they're just beautiful. And I wanted to convey that in high school, and I made that video using iMovie and this really awesome soundtrack from the Piano Guys on YouTube. They make some really nice instrumental covers of good songs, and it was great, and it got a lot of views, and I used it in my college apps at the time, and it was a beautiful thing. And that's like 1 in like 10, 1 in 50 chance of me doing that, because that's like when you have a really compelling story to tell, when you have a feeling to convey, and the music matches up, the visuals match up, and when everything is aligned perfectly, you get one of those videos. And that's like, that to me is a little bit rare to do, and I have yet to figure out the magic of that and how to replicate that, right? It's definitely a journey. I feel like it's you have to explore different media, different kinds of music, right? What does it make you feel? Shoot different types of video footage and photography, really just play with that. And it's like it's more of a marketing thing. I feel like it's not exactly this project per se, but it really is like trying to sell your product, um, in a sense, right? It's like it might not be like a physical sale, like I'm not selling you this plane, but I'm selling you the idea of making this plane in a compelling and beautiful manner through a video, right? And that's kind of the, kind of the feeling behind that for me is, these projects, they're great, but making the video, that's hit or miss for me, really. You have to have the right inspiration and then the right music and then the right footage, which is really hard to make everything happen at, all at once. So this looks great. This looks okay. This is looking all right. It might be a little bit bloated in the middle, but I think it's workable. I feel like the problem here is that the core skeleton, the structure inside is a little bit too wide. If it were a little bit narrower, this skin panel would add to that width, and it would be about the right size. But since I cut the cross sections at the larger actual size, the offset from the panel just makes it look a little bit large. So that's rather unfortunate. I don't think I can correct that because these cross sections took a lot of time to make. But it's like, it is what it is. We're gonna stick with it and try and do the most with what we have here. All right, so I've taped the middle belly portion here. Really, the only problem is that these locations here really want to pop out. So if there's like a way to compress this, that would be magic. So I don't know. I'm probably gonna grab a little piece here and tape the aft ends together to really seal that up and keep this tight. But that's not gonna guarantee that this middle part is gonna be tight. It's literally just the end part here. So if you do that and you pinch it down, looks decent. You could do the same thing on the other side. And that's pretty great. Yeah, this front bit is going to be difficult to model. I am not denying that. It is just a fact. So let's see, we're at about 83 minutes, so we got like, I usually go up to 130, so that's like 50 more minutes. Let's see, work on the back portion here. Wondering if I should have like folded this in, but this gives it like a nice transition out towards the wings, so I'm not too against this idea. It's just the cross section, right? So this is a nice transition. I don't blame that for looking bad. I blame the internal members here that I made a little bit too wide. Should have double checked. God damn it. Anyway. Well, this model isn't supposed to be like scale or accurate or anything like that. It's supposed to be a flight model, so the fact that it looks nice, it looks decent, is a plus. It's supposed to be a plus, but I've made it kind of the primary reason behind this project. It's more like a sculpture at this point. So, but as long as it flies, it'll add up, it'll make up for these geometric inaccuracies, right? I feel like, I don't know, up to you to decide for that. But yeah, all right. So, let's see, I have an idea for the nozzle, but it's gonna require this bottom panel to be completed first. Also, I have an idea for this little ventral fin, right? It needs to be attached to the outer skin. I thought about like putting it inside, like making the anchor on the inside here, and then poking like a slit right in the skin, and then like pulling it out there. And then I was like, that's like structurally like not good for like the slit, because that's a high stress concentration right there. So if you move the ventral fin, it's gonna rip the paper, rip the skin. That wouldn't be good. So yeah, I'm just like talking to myself at this point. I'm just kind of like train of thought, like stream of consciousness, just blabbering away. So I apologize for that. Um, so I'm just reading some of the comments here. Problem is editing it is something watchable. Yeah, I agree. My current cameras are phone Galaxy Note 10 Plus and my webcam Logitech Brio. Yeah, I want to get like a USB-C webcam, because that'll help make these videos a lot easier. Like it'll be a lot less wear on my phone, right? Because every time you use your phone to live stream, you're using your phone's CPU and camera, and that's gonna wear out your phone, I feel like. So if you use like a dedicated webcam, it might be better, and your computer's processor, right? PC has dual Titan RTX running in NVLink and an i9. Wow, an i9. That's incredible. So not bad, but not amazing. It is good for CAD modeling though. So yeah, I encourage you guys to use new tools like CAD. It's great for hobbies like this. Astro Video is excellent. Thanks, man. I appreciate it. I put a lot of effort into that. Excited to see the next iteration of that series. Yeah, the M1 is still in progress. It's oh god, this is taking a while because I don't want to screw it up, but at the same time I know it's not gonna be perfect. So I'm just like in a virtual stalemate here with my motivation, and my motivation to complete the project versus like I don't know, my desire to complete it. But it's looking good so far. The slat and canard actuation mechanisms are separate, but they work better than this integrated mechanism, just because they're more precisely made, tailored for each control surface. So that's good. I just have to like find the motivation to panel it. I think the greatest difficulty in that project right now um, is the underside, really, the nose section, which with this I've actually explored some of the methods that I could use to complete Astra M1. So that'll be interesting to see, like incorporating some of the build techniques in this design into that custom original design. So that's going to be exciting. I might work on that, I might not work on that as the next project. I feel like it could be pretty exciting, but it won't be like the full process, right? We'll be starting with like a half complete plain base, and we'll go from there. But I feel like that might be an interesting project next, to do next. Yeah, really the underside is the most troubling bit, because I want to incorporate like a ventral fin, but the structure around the belly isn't really conducive to mounting something like that. And I really need that fin, not for aerodynamic purposes, but rather for like a handle, right? Because if you notice, this is a very difficult plane to hold once it's complete, because it's round on the bottom here. So it's gonna be hard to throw, but like with the Astra, I want it to be flight capable, period, right? So you need that solid handle on the bottom, disguised as a fin, and there's no structural area currently on that design to allow for that. It's just kind of one of my oversights about the design, right? I included the slat mechanism, which there's a straw down the middle, but then that straw mechanism interferes with the mounting location of the handle, which is probably pretty important. more important than the slap mechanism itself. So it's just kind of an oversight that I didn't pay attention to. So now it's making my life difficult. If I can't get the underside to look great, then the whole project is just kind of paused as is. So hopefully, we might work on that as a next project. Let me know if that's something you would like to see, or if I should work on a different plane or anything like that. Just add those suggestions. I know someone in a previous stream commented, make the Shinden J7W1. It's like the World War II era canard plane from Japan. I'm not sure, I'm not sure if I'll make that, but I have that in the back of my mind. So if you comment something, it'll be in the queue. You never know when it's gonna come, but it's gonna be there. So I'm just blabbering on at this point. I'm so sorry. We're not getting much done. We're spending 2 hours to create one belly panel here for this F-16. It's not that much progress, but oh well. Yeah, let's see if there are any chats. Yeah, no, that's pretty much it for now. Okay, so it looks good. The front intake part needs a little bit of work, and the back part here needs a little bit of work. A lot of bit of work, actually. From the looks of it. I think it does taper. It's just how much do I want to taper? Alright, this is gonna be a little bit tricky because this is at an angle. So we're gonna have to try and model this to the best of our ability here. Alright, so that's not a straight edge, unfortunately. I'll cut half a cone, try and model this. Show yeah, this is gonna be a little bit tricky. Tail end of the aircraft is always a little bit difficult because it's not continuous. It ends in a sharp nozzle. God, this is alright. I did not think this through. Let's see. We can take a template like this. Oh, I'm so sorry to cut up this drawing sketch, but oh well, it's a sketch. As long as the ideas behind the sketch are thought out, then we're all set. Alright, let's do the same strategy that we used before, a temporary adhesive attachment to the structure itself, which is going to be right about here. Alright. Alright, I grabbed the tail. That's not great for the tail structure. That's exerting a force on the inner mechanism, which is not great, not ideal. The only force the mechanism should experience is aerodynamic load. That's the only thing that it should experience. Right, the air pushing on the control surface, which in turn pushes inside on the mechanism. But silly me, I done goofed. And alright, so I'm gonna draw a rough shape here. This is highly sketch. And I don't mean it in what I'm doing right now. I mean it dude, this is like sketchy, bro. like, this is like not how you design airplanes. Like, if I showed this to like someone from Boeing, they would be like, bro, do not hire this person at all. Like, the way he approaches things is like too rough and rowdy. I guess, you know. Oh god, all right. Let's see if this works. So I'm gonna cut this. And then I'm gonna cut this, and it's gonna be great. It's gonna be great. It's gonna be like a little square rectangle thing. And then, and so okay, we can like collapse this in. Yeah, it's gonna be a little tough. Well, when has it never been tough? When has it not been tough, right? Okay, so this looks decent. This looks decent. This is why we use cardstock, because this printer paper stuff is like way too weak. Cannot handle this. Okay, so I guess we could like tape this. Alright, sorry, you guys can't see, but you can tape this as is. Like on the left side here, just like a horizontal attachment to the side. And then I guess this shape will just work. I don't know what, like how this works, but okay. I guess we will just use this then. Now I just gotta transfer it onto a piece of cardstock here. This is quite interesting. Very interesting approach. I am not complimenting myself, I am merely commenting on the fact that this is I have never done this before. I don't know what I'm doing. Alright, so this, okay, yeah, I don't even know if this geometry is good. I just want to define this a little bit better. The end is gonna be like paneled to heck. Right? Like, I'm gonna overlap imperfections so much that you won't even know like what the panel looks like, but it's just still, I don't know, in my brain, good practice to try and get it to perfection on the first try, which is gonna be difficult. Making airplanes, oh shoot, alright. Yeah, making airplanes isn't easy. This is a pretty extra hobby, if I do say so myself. It's not easy at all. Yeah, most people, like, you know, they just go out and play sports, you know, enjoy life. But me, no, I need to make airplanes. Like, that's just what I live for, man. This is not really just airplanes. I think it's just making great things. But I've already like professed my love for creating beautiful things earlier in other streams, so I won't do that again. But airplanes are beautiful, so had to say that. Just had to. Shifted it. Damn it. This is why you can't have nice things anyway. Alright, yeah, so just draw that there. Draw that there. should be good. I'm not sure. I'm not entirely sure. This could go terrible. Terribly. Alright, so let's cut that. Just gonna trim that, and then this side right here, and this. Yeah, that's the thing, right? Like with 3D modeling, you can get the exact shape that you need. But with this, you're literally just fighting the material as you go to try and get the right shape. It's more like sculpting rather than defining a shape through geometry. So this method is not as precise, not as accurate, but it gives you really organic looking shapes. I should probably erase that little line there. The other method, on the other hand, I feel like, it's great. It's just sometimes when you're not experienced in CAD, and I say this for myself, but also like for a lot of other people, when you try and CAD like an airplane, it looks very amateurish, unless you're really good and like attuned to the details. So it's just gonna be a little bit tough to make like a good looking airplane in CAD and then translate that into physical form, right? Because the physical thing is always gonna look different than the real life, or than the model, right? It's gonna look different because of manufacturing tolerances, it's gonna look different because of lighting and things like that you need to worry about. So right now I'm testing out fitting it on the inside. I don't know if that's a great idea. That might be the worst idea that I have ever had. This is like bad, I think. No, aerodynamically it's great because it's a step instead of like you're not introducing a surface on the outside here. So aerodynamically it's great, but structurally I'm not so sure. But let's go with it. See what we can do with this. I'm just pushing the mechanism a little bit so that we get more clearance here to work with this section here. Alright, so I'm gonna align this with the back end here. So whatever length this is, it is what it is. I should probably make like a copy of this before I install it. Yeah, that's good. Alright. I'm just gonna assume that. Ooh, okay, I forgot the rear edge here. Damn it. I guess one of the things that I kind of want to do when I get like a house, when I can create my workshop, is explore the application of steam. Like if you apply steam to this cardstock material and then have like a 3D printed mold, you could potentially like form these complex compound curvature shapes with 3D printing and material hackery, I guess. Because paper in the end, it is just cellulose fibers bonded together. So if you steam it and make it soft, it could flow like a fabric and, you know, be bent in multiple directions. So I want to explore that. I just don't have the infrastructure to do it right now. I mean, like, I could put this in like a pot and then try and boil it, but I just don't think that's the best way to go forward. But I don't know. I might try that as a material exploration exercise. I do need to like 3D print like a mold, like, you know, a male part and a female part, and then, you know, compress the part, you know, the cardstock in between to like form a very nice shape. And once it dries, it'll be like a perfect cockpit shape or whatever, you know. And with that, we can even do like plastic. If we can 3D print like a mold like that, can like heat up some water bottle plastic, make it soft and pliable, put it in the mold, compress it, you know, trim the edges, and then you have a perfect canopy shape. So I don't know. That's just like a random thought that I had. That would be pretty sweet, to be honest, because then your builds would look so much better, and you know, just exploring materials and processing methods like that is kind of interesting to me. That's like beginner level stuff. Maybe when I have my own studio, like I'll even explore like different chemistries. You know, like a DIY scientist here, just testing out different plastic chemistries or rubber chemistries to make like very durable gliders. I don't know. It's just some random ideas that I had. I don't know why I sounded southern for a second there. Sorry about that. All right, so this is looking all right. Not too bad. So we're at 107 minutes. Today's stream is going by a little bit faster because I actually am not exhausted for once. I need to cut a little bit more off of this. We don't have enough clearance for that fulcrum that in the mechanism. Oh my god, this is like bad. It's like stuck. Alright, there we go. Oh boy, here we go. Alright. I've taped this in place. In the real life F-16, there's like a vertical edge here. It's quite a distinctive feature, I would say, but we are choosing to neglect that in this build for simplicity's sake. Just want to point that out. I do realize it's there. It's like one of those smaller features, like the diverterless or the diverter plate, the splitter plate, that I'm just choosing not to include in the model for simplicity. So this looks okay. The only problem is like this part is like collapsing in on itself. So I guess the answer is I should tape it on the outside. God damn it. So I'm gonna just rip this out. Yeah. That way we don't have to reapply the tape. Oh my god. I can't believe I just did that. Anyway. This yields an aerodynamically unfavorable configuration, but it's a structurally great configuration. So what we're doing is we're allowing the back panel here to rest on top of existing geometry so that, you know, it doesn't cave in. This is pretty key. I'd say that's more important to the aero than panel junctions, but you know, it is what it is. All right, so this is taking a while. I'm just gonna say it is taking a while. This piece of tape is annoying as fuck. All right. Know why? Cause like I drew like a mark and I forgot to erase it. Now it's just hanging on to the tape, and it might get transferred to the cardstock underneath, which will suck. Damn it. Alright, here we go. Like that. Yeah, I'm just gonna replace this with a clean tape piece. This is purely for aesthetic purposes, again, right? You gotta know when to make these decisions and when not to. So, anyway, here we go, and then all right, yeah, we should probably tape the back end here. So that would involve making this thing flat first. I just hope that, you know, this panel isn't exerting a force on the elevator, because if it did, then we would be screwed in terms of actuation. I mean, not that like we don't even use the actuation all that much, to be honest, so it's not a huge deal. But a lot of friction with this elevator tail here would kind of suck. It would defeat the purpose of a mechanism. So let's try not to make that happen. I don't think it'll be a problem, to be honest. It's like it's very close to the center of the fulcrum, which is good. That means the mechanism has more leverage than the resistance that is put up by the panel structure, underside panel structure that I'm taping right now. Nice. Oh man, this panel is beefy. All right. So what I think I'm gonna do here is let me try and complete my thought for a second there. I kind of want to like cut little slots here and then fold this excess over, but I also realize we need to get the other side in first. Like if we do this and then assemble everything, let me just erase the panel lines real quick. If we do this, then we can like clean up the panel line detail later. Not have to worry about that. Alright, so something like that. We can trim down the middle to get a perfectly center line. Perfectly center line. Oh man, could you be more redundant? Anyway, I am like stream of consciousness just speaking. Anyways, some comments. F-14 Tomcat V3 or V4? I forget if you made a V3 or not. I made a V3, I just didn't make a video for it, and I gave it away to like a family friend. You know, they had a kid that was like, oh my god, the wings move, and I was like, yeah, it does, do you want it? I just gave it away. So I forgot if you made a V3 or not. I don't know, maybe an F-14. I could work on the Astra or the F-14. What about a handheld steamer for laundry? I thought about that. I need to get one of those because I do need to straighten out my shirts too. Um, but I feel like for this, you need like a fully immersed environment for the steam to really work. Because it needs to saturate the material, right? To really soften it up like that. You can't really do that with like a handheld steamer. You need like a closed pot or container of some sort. You know, that's just kind of my feeling. But feel free to experiment if you have one, right? You can do some material experiments, things like that. Um, that's definitely like the fun aspect of this because most of the time I don't know what works. There's nobody to tell me like what I should or should not do, which I enjoy, right? If you tell me something, great, but have you done it? you know, just check in there. Um, but it's like there's like no expectations out of this, right? It's literally just me tinkering. And so if we do end up making something cool, then it's like, wow, great. But if everything fails, then it's like, oh, cool, we learned another way not to do this, right? Um, so I'm just saying that out loud here. If you want to try, doing the hand steaming thing, by all means, go ahead. I'm not stopping you. It's a great idea, and I think they actually use it in like woodworking, right? For soft wood pieces. And you think of wood as like a pretty hard, stiff material, right? But it can actually bend significantly. So I don't know. That might be worth checking out. For paper, I mean, because if you work with paper a lot, this new technique of like steaming things would open up a whole new amount of possibilities. Right? It's like a technology improvement thing. Because once you're able to unlock a certain material property, then you can make some pretty cool stuff. All the ages. I had a professor in college of material science and engineering, Math C. Um, he told us, and this quote, I'm gonna butcher it. It's not gonna be exact, but the idea behind it has stuck with me ever since. It's that with new materials, you're able to unlock new possibilities, and that's what we designers and structural engineers really enjoy is those new possibilities, but they're not possible without these material advancements, right? For example, in jet engines, like when I work on my task and things like that. All right, a lot of the bearing races on the inside. Okay, this is gonna be a little complex sounding, but bear with me here. Right, like if like fidget spinners, right? Those things exist inside jet engines, like those little ball bearings, right? Except they're massive. These balls are like an inch and a half, and there's like 100 of them or so. I don't know. I don't know the exact number, so you shouldn't quote me on this. But they roll on these races, these like little C channels that are, like a circular donut, right? Think about that. And those things are in a very high temperature environment, and they would not survive without material advancements, right? So like these high temperature alloys are made of nickel superalloys called Inconel. And that's like an innovation in and of itself, because without that material you might have to replace that with like steel or something, and you would have to use a ton of steel to make it withstand that temperature. I'm just saying, for example, you wouldn't actually be able to make a jet engine without Inconel at this point. That's efficient, and things like that. Right, so new materials really do advance design, engineering, and things like that. It's really the foundation behind everything that we make, right? And so that's why it's so important, and that's why material science is so important. Um, and you can get really deep into that stuff, right? Like fracture mechanics, things like that. Um, but I think we might need a panel down the middle here just to smooth things out and make it look a little better. I'll also say, like, we do probably need to trim this section here in preparation for the nozzle. So I don't know. But yeah, anyways, like, new materials. There are always new methods to work materials. That's true innovation right there. That's, you can't unlock these new features, these new ways of making, without improvements in material processing. So definitely try doing that. I kind of want to steam something, but probably don't have time today to do that. But I just grab like a pot or something, and then when I have my own house, I can like create a bonfire or something, and just like have fire in the backyard and boil a pot of water, and then just like have skewers across the pot. I mean, I guess you could do it in the kitchen, but it's just like I don't know. In an apartment, it's just kind of sketch. I guess I could make it work, but I don't know. All right. So, anyways, I think we might have to cut this and prepare it a little bit. I do want to get like what was this measurement? I think it was like 9, right? It was like 9 centimeters down the length. Nope, it's 6.5. Damn it. All right. No. Actually, it's 7. Is it 7? Yeah, it's 7. Yeah. Okay, so 7, and then we want a little bit extra, so probably 7.5. No, seven's fine because we're gonna cut off this area anyway. So I'm gonna do 7 by, I don't know, let's say 2. 7 by 2, and then like make a zigzag pattern to make it fit in the aesthetic of panels. Yeah, this tail end is gonna be difficult to make. But right now, this is what it looks like. It looks absolutely hideous. We'll need to clean that up significantly, and the intake needs to be worked on as well. Got like 7 minutes left. I don't know if we'll complete the F16 today. We will probably complete it next time for sure. Just need to figure out this front intake business and then the nozzle, and then we'll be all set. But for today, I'm just gonna continue making like a strip of material here to cover this up, because this seam is diagonal. It's not straight, and if I cut it straight, then it's a very precise thing to do, which I don't think I'll be able to do a good job at. So we're just straight up going to cover it up. And also, like, I need to like tape this down. Oh, shoot, sorry about that. So put tape there, and then just squish this down a little bit, and then squeeze the sides in, and then place that down. So again, this is not ideal. Wow, you can really see the slats being deployed and the horizontal stabilizers. This is like an extreme position. You would never find this in a real flight. This would like break the airplane. So, but anyway, I'm gonna like compress this a little bit and then make like a ring to like capture this. I don't know, bro, like this tail is just too difficult. All right, anyways, enough of that. I need to make the part here. really get started on this and then complete it next time. Right, let's check comments. No comments. Good. All right. So we're all set to go. We have 7 centimeters here. Realistically, we don't even need that much, but we're just gonna give ourselves an extra bit of wiggle room here. For the width, again, I'm not sure. Maybe like 2.5. If we give it 2, then let's just give it 3. God damn it. All right, whatever. 3. That should definitely be enough. And then 7 again. I don't know if that's perpendicular. Let's measure 3. Shit, alright. Looks like we're gonna be missing a little bit of our corner here. But that's okay. We'll keep that at the tail end because we likely won't need all 7 centimeters anyway. And then the front here, this is gonna be interesting. I'm gonna have to create that pattern of zigzags. So we're gonna do 1/2 centimeter here, 1/2 centimeter on the other side. So got a line like this. And we got, what's it, 3, so 1.5. And then what's half of 1.5? It's gonna be 0.75, which is gonna be right about here. And then 0.75 on this side. It'll be right about here. Alright, and then we're just gonna eyeball the center here. That's terrible. There we go. That's why. I'm bad at drawing shapes. God damn it. And this guy wants to be a designer. Just look at that. I give it that engine transition panel shape. I don't know why they actually do this on real life planes, so if you know, please let me know. I want to say, like, I don't know, it's just better fitting than straight lines, because if you're off at an angle, you have at least like some sliding action between the pieces instead of direct compression or you know, things like that. Looks good. Looks good. Probably gonna flip it over to ignore all these panel lines. Alright, you know what? We're almost at 1:30, so I'm gonna call it for today. Next time we'll definitely assemble this and continue from there. So yeah, take care. Thanks for watching. Stay safe. We've just gone over the 1:30 mark, but just wanted to say goodbye to you guys. All right, take care, work on your projects. again, stay safe, and I'll catch you guys next week. Thanks for watching.